So this is your rectangle inside a circle. And we name these vertices A, B, C, D of the rectangle. The length of AB is given to be 5 centimeter, and the length of AD is given to be uh, length of AB is given to be 12 centimeter, and the length of AD is given to be 5 centimeter. And we have to find out the area of this region. This shaded region, we need to find out the area. Okay. So what is the area of this shaded region? It is area of the circle minus the area of the rectangle. You know the length and breadth of the rectangle, so finding out the area of the rectangle is not a problem here. Okay, the problem here
Good morning,
is
sir.
to, yes,
Good morning, sir.
good morning. The problem here is to find out the area of the circle. In order to find out the area of the circle, you will require the radius of the circle. Okay, now in order to find out the radius of the circle, what you do here is that you join B and D, say with the help of a dotted line, we join these two. Okay, now once you join, the point that I'm trying to make here is that once you join, this line will be the diameter of the circle. And why should it be a diameter? I've given you the reason here. This theorem is not there in your syllabus for the time being. Okay, that is, if you remember in class 8, we had done a theorem where I said that angle in a semicircle is a right angle. If you remember, now just the converse of that
Yes,
theorem
sir.
is just the converse of that theorem is that any angle on a circle, if it is a right angle, then it has to be subtended by the diameter. So the point that I am trying to make with that, with the help of that theorem, is that this angle is 90-degree, then this BD, this line, has to be the diameter of the circle. That means diameter means it has to pass through the center of the circle. Say the center is somewhere over here, I mark it, say O. Okay, so the center will lie on this line. Just because this angle is 90-degree, just because this angle here is 90-degree, BD will pass through the center. If it was any other angle, then it would not have passed. Okay, so that is why BD becomes our diameter. And how do I find BD? BD is the hypotenuse of this triangle, if you see here. Okay, ABD. So you can find out the hypotenuse by Pythagoras theorem. And the hypotenuse is also the diameter. Once you get the length of the diameter, you can find out the length of the radius also. Okay, so let us proceed to find out the length of the diameter. So what is the length of the diameter here? BD square by Pythagoras theorem. BD square is equal to AB square plus AD square. AB square 12 square plus 5 square. 144 plus 25, which is 169. Therefore, what is BD? BD is square root of 169, which is 13 centimeters. So that means diameter is 13 centimeter. That means what is radius? R. Radius is half of the diameter, 13 by 2 centimeters. You can write this as 6.5 centimeters also. But when in calculation, it is better to use the fraction 13 by 2. So what is the area of the shaded part? Area of the circle. What is the area of the circle? They have asked you to take pi is equal to 3.142. Let us write first simply pi. Pi into r square. This is the area of the circle. Okay. Pi into 13 by 2 square minus area of the rectangle. What is the area of the rectangle? Length into breadth. 12 into 5. Okay. Now they have asked you to take pi is equal to 3.142. So you put 3.142 into 13 by 2 into 13 by 2 minus 60. Now how do you calculate this? You convert 3.142 to a fraction. Right, this has 3142 divided by 1000 into 13 by 2 into 13 by 2 minus 60. Okay. So therefore, you can cancel this now with 1571. Okay. So that means you get this as 26. If you multiply 1571 into 13 into 13, you get this as 265499 divided by 2000 minus 60. You can take the LCM here. Okay. Or what you can do here is that you can find out the value of this fraction in terms of decimal, and then you can proceed. Okay. So what you do here is, if you want to find out the value of this fraction, then how do you find out the value? First of all, you see there are three zeros here, right? So you shift three zeros from here. 1, 2, 3. So you get 265.499 divided by 2 minus 60. Okay. Now here, now you can, it is easy to calculate. That means now you can divide 265.499 by 2 to get 132.749 minus 60. Then they have asked till how many places of decimal. Let me first calculate this. This should come to 132.749. And they have asked till how many places of decimal? Two places of decimal. We have got till three places of decimal. We'll round it off. 132.75 centimeter square, correct to two decimal places. Correct to two decimal places. Okay. Any questions in this? Calculation is okay. Main thing is calculation here. You understood the calculation?
Yes, sir.
Let us proceed with the next one. In this figure, two circles are given. They have different centers. Now, this is not a circular ring. Okay. Remember, this is not a circular ring because the centers are different. Circular ring means the centers have to be same. The circles have to be concentric in order for them to form a ring. This looks similar to a circular ring, but not actually a circular ring. Can anyone tell me what is the shape? What kind of shape this is? Can anyone tell me what kind of a shape this is?
Sir, jewelry, har.
No. Exact term for this. Sonam, can you tell me what kind of shape this is?
No, sir.
Sir, inside egg part,
Egg, yes, sir.
Sir,
Like it.
Who can tell me
yellow
what
part,
shape this is?
yellow part, inside the egg, yellow part.
I'm looking for the exact word.
Yolk.
Naila, can you tell me?
Bicentric.
Who said that? Ashad Iqbal? Now Asad Iqbal will not get the attendance, okay? Sneha Chaurasia?
Yolks, yolks,
Understood? He's not there actually.
Yes, sir.
So you don't give him his attendance.
Okay, sir.
Paramjit Gill. He will also not get the attendance. Paramjit. Okay. Sneha, can you tell me the exact name of this shape?
No, sir.
This shape actually looks like
Ovoid.
this shape is a religious symbol also of the Muslims, of the Jews. Now, can you give me the name of the shape?
So moon.
Sir, moon.
So
It is
moon.
called a crescent. It is a phase of the moon. So you have two centers here. Okay. Two different centers. As I told you, this is not a case of a circular ring. This is looks like a circular ring, but it is not a case of a circular ring because they have two different centers A and B. And what else is given? In the given figure, two circles have centers A and B touch each other at the point C, touch each other at this point C. If AC is equal to 8, AC is equal to 8 means this length is your 8. Okay. This length is your 8 centimeters. And this length AB is 3. That means this length here is 3 centimeters. Okay. Find the area of the shaded region. Now, in order to find out the area of the shaded region, the procedure is exactly the same as circular ring. Okay. But the calculation will be exactly the same as circular ring, but it will differ, but it is not a circular ring actually. So you need, first of all, what you need to identify is which is the radius of which. So first of all, what you observe is that BC is the radius of the smallest circle. This, right? And also what you observe is that this AC is the radius of the larger circle, right? This is what you observe. So what you do here is, what is the length of BC given to you? BC is given to you as 3 centimeter. So you know the radius of the smaller circle. And what is the length of the radius of the bigger circle? EC. This is given to you as, oh, AB is given to as 3 centimeter. My mistake. This radius is not given. AB is given to you as 3 centimeters. That means this distance between the centers, this length is given to you as 3 centimeters. Okay. If you read the question, AB is given to you as 3 centimeters. So therefore, what is um, the radius of the smaller circle? A bigger circle, in fact, AC. Radius of the bigger circle is
Sir, 8 centimeters.
8 centimeters. And the radius of the smaller circle here is 8 minus 3, not 3 centimeters. Because this length will be how much? This length
8
is
minus 5.
8 minus 3
5.
is 5 centimeters. Okay. So let us call this bigger radius of the larger circle as capital R, and let us call this as small r. Okay. So what is the area of circle with center A? Bigger circle.
Sir,
Ah,
pi
yeah.
r square
Or let
square.
me do it together. area of the shaded region. Area of the shaded region is equal to area of the larger circle, right?
Yes,
Pi
sir. Minus
capital R
area.
square
Area of the
minus
smaller
area of
circle.
the smaller
Pi
circle.
capital
Pi
minus
small r.
smaller square.
Now, remember, as I told you, although the formula looks the same, but this is not a circular ring. Okay, the formula looks the same, but it is not a circular ring because the centers are different. So now you put the value of small r and capital R. Pi. Don't put the value of pi right now. Pi capital R square is 8 square
8 square
minus pi small r
minus
square is
pi 5
5
square.
square. This is 5 square. So what you get here is 64 pi minus 25 pi, which you get as 13 pi, 39 pi.
39 pi.
And this is 39 into the value of pi. How much have they asked you to take? They have not specified. So you can take 22 by 7.
20 is 22 by 7.
So 858 divided by 7. You multiply and then you divide to get 122.57 centimeter square. So this is what the area of the shaded region is.
122 point.
So this is a fairly simple problem in that sense. Okay.
Yes, sir.
Yes, sir.
Let us do the next one. Here you have 4 quadrants given to you. Four quadrants are given to you, and the region that is
So
shaded
this
here,
is a kite.
this is a
Kite.
kite. No, it's not
No,
a
this is
kite.
No.
not a kite.
This is not a rectilinear
Uh,
figure.
Starfish.
Sir, diamond.
Can you tell me why it is not a rectilinear figure?
Sir, because it has curves.
Yes, it does. It is not made up of straight lines. That's why. Okay, so the this is the region that you have to area of this region that you have to find. Okay, and the quadrants are each of radius 7 centimeters. Now, what do you mean the quadrants are of radius 7 centimeters? Can you see any quadrant here? Can you see any quadrant? Well,
No,
first,
Sir,
sir.
one.
what is the
Sir,
difference?
A.
Tell me what is the difference between a quadrant and a quadrant of a circle? If I say a quadrant and a
Sir,
quadrant of a circle,
sir, quadrant means so 1/4 part of any shape,
any shape,
and quadrant of a circle means one
1/4
fourth
of a
part of
circle.
only circle.
So here, when they are saying quadrants, what they mean here is not quadrant of a circle. What they mean here is these four, uh, the plane has been divided into 4 parts. This part, this part, this part, and this part. All these are called quadrants. Okay, the entire plane has been divided into 4 parts. Each of them is called a quadrant here. Okay, so now the question is how to find out the area. So what you will do here is you will draw the quadrant of a circle. That is, you will, with the help of a dotted line, you will complete this quadrant of a circle. Okay, and what is the radius of this quadrant given here? It is given to be 7 centimeters. Okay, so what is the area of only this part? Only this part.
7 into 7.
It is the area of the square, right? Let us call this square.
Area of the square minus area of the
Let us
shaded
call this
region.
O. Area of the square AOBP minus area of the quadrant, right? Okay, only area of this only blue part that I have shaded is area of the square AOPB, right?
Sir,
Yes.
sir,
Hmm.
sir, ABP is a quadrant of a circle.
Yes, quadrant of a circle.
Oh,
ABP is quadrant of a circle. That is why I have joined with the help of a dotted line so that I can finish the quadrant of a circle. I can complete the quadrant of a circle. Okay. So area of the square AOPB minus area of the
area of the quadrant
quadrant.
of a
Okay.
circle.
So area of each shaded quadrant. And see, I'm not writing quadrant of a circle. I'm simply writing quadrant. Area of each quadrant means only the blue part that I'm talking about. Okay. The area of each quadrant is equal to area of the square which square AOBP minus area of the quadrant of a circle. Okay. Area of quadrant, let's say, let's call this quadrant, let us call it ABP. Okay, so this is area of the square is how much? 7 square. And area of the quadrant will be, what is the radius of this quadrant here? Quadrant of the circle? It is 7 centimeter only radius. So this is minus 1/4 pi into r square. So this is 7 square minus the value of pi. How much have they asked to take? They have not specified. So let us take 22 by 7. 1/4 into 22 by 7 into 7 into 7. So these two cancel off. So you get 49 minus,
Sir, 4 and 2 will be also cancelled, na?
yes, you can cancel this also. This also you can cancel. So you get 49 minus 77 by 2. So if you take the LCM, you get 98 minus 77 divided by 2. So you get 21 by 2 centimeter square. Leave it as a fraction. So area of this blue shaded part, I've got 21 by 2 centimeter square. So what is the area of all the the entire shaded part? There are four shaded parts like this. So multiply it by 4. Therefore, area of the shaded
Yes,
region,
sir. 21 into 2.
4 into 21 by 2. You cancel this. You get 42 centimeters square.
42.
Okay. So that is how you find out the area here. Let us move on to the next problem. There are 4 circles here in this problem given. And 4 circles, the centers of these 4 circles are the vertices of a square. Okay. The centers of these 4 circles are the vertices of a square.
Sir, this is easy.
This is
Sir, easy. Sir,
easy.
I
Won't.
understood what to do.
So how easy is it? Tell me.
Sir, first we will find the area of all the 4 quadrants, and then we will find the area of the square, and then we will minus. We will get the area of the shaded region.
First, you'll find out area of what?
Sir, the circles.
Quadrant.
Area of the circumference.
So first we will find the area of the circles 4, and then we will find the area of the square, and then we will minus it.
No,
Then
not as simple as it
So
looks actually. Let me draw a freehand because it will take time to draw a perfect figure here. Complicated figure. So you have 4 centers
yes, sir.
and you join this.
Sir, we'll get the radius also, na?
Yes,
Radius.
radius, sir. Radius and sir,
You will require the
circumference.
radius. You will require the radius because without radius, how will you calculate the area?
Yes, sir.
Sir, and the circumference.
You don't need the circumference. Here they have asked only of the area.
Okay, sir. Then the radius
But in either
1 by
case,
2.
even if you want to find out the circumference, you will still need the radius. Just as in a rectangle, you need the length and breadth. If I give you the length of the
Yes,
diagonal
sir.
of a rectangle, can you find out the area of a rectangle?
Without radius, we cannot.
You cannot find with the, that means for a rectangle, you need the length and breadth. If you don't know the length and breadth, how will you find out the area? So
Yes, sir.
same,
Yes, sir.
same thing in the case of a circle.
Sir, all
Everything,
the circles are equal.
all the circles are equal means?
Sir, here all
Yes,
the
sir.
circles
In
are
the diagram.
equal.
Yes, equal circles. They have the equal radius, so they
Okay.
are all equal circles. Okay, yes. This is the shaded region. Okay. And the side of each square is given to you as 14 centimeter. So that means this length is given to you as 14 centimeter. And so is this
Sir,
length.
I got it. Sir, first we will find the area of the circles and then we
First, you
will
will find out, wait. First, you will find out the area of the shaded region inside the square. Okay. And what is the shade?
Yes,
How
sir.
will you find out the area of the shaded region inside the square? It is area of the square minus area of the four
You
quadrants,
have
right?
this. Yes, sir.
Next, what you will do is you will you will find out the area of the shaded region outside the square. How will you find out the area of the region outside the square? Area of the region outside the square uh, is three times area of this major segment. Three times area of this major segment of each circle, right? And how do you find out the area of this major segment? Area of the entire circle minus area of this sector. You get 1 and then you multiply by 4. Okay. So first we find out area of the shaded region inside the square. Area of the shaded region inside the square. What is it? Area of the square minus area of the four quadrants. Area of the four quadrants of a circle. Of the circles. Right? So area of the square, if each side of a square is 14. So area of the square is 14 square. And what is the area of the four quadrants? Four quadrants are there.
14
So write 4.
centimeter.
So write 4 first for the four quadrants into what is the area of each quadrant? 1/4
1 by 4
pi
pi r square.
r
R
square.
square.
Now the question is, what is the value of r square? What is the value of r square?
Sir, r is 14 by 2.
Pi, yes, 14 by 2. Because if this entire length is 14, then this length is 7 and
Yes.
this length is also 7. So the radius of each circle is 7. So pi into 7 square. Okay, so this gives you, now you can put the value of pi. This is 196, 14 square. Pi, value of pi is not specified. You put 22 by 7. Okay, so you get 196 minus 154, which is 42 centimeter square. This is the area of the shaded region inside the square. Now, how do you get the area of the shaded region outside the square? Area of
Minus.
each shaded region. You remember the word each. By each means I'm talking
All the
here
four.
only about the blue one that I have shaded. Okay. So area
What?
of each shaded region outside the square is equal to area of the circle minus area of
The quadrant of the circle.
Four
quadrant
quadrant
of the circle.
of the circle.
Okay, and what is the area of the circle? Pi r square minus area of each quadrant is
42.
1/4
1
pi
by
r square.
4 pi r
You
square.
take the LCM, you get 4 pi r square minus pi r square by 4, which means 3/4 pi r square. In fact, from the shape only you can guess. If you see the shape here, the blue one that I have shaded, this is 3/4 of the circle, right? This is 3/4 of the circle, the one that I have shaded
Yes, sir.
in blue. That means even if you don't do all this, pi r square minus 1/4 r square, you can write directly that it is 3/4 pi r square, because you know it is 1/4 of the circle, 3/4 of the circle. Okay, so anyway, so it is the area of the circle minus area of the quadrant of the circle. So now we put the value of the radius, 3 by 4, put the value of pi, and the radius of each circle you know is 7 centimeters, 7 square. So one cancels here and this 2 cancels here. Okay, so you get this.
33 by 14.
Now see here, there's a small mistake here. Okay, the point is that I could not, maybe I have forgot to attach the sheet. Okay, so you just copy the area of this 3/4 of the circle from the video, because this is a part of some other problem. All this. Okay, this page that you see here, page number, this page number 11. Okay, page number 11 is not a part of this problem. Okay, it is a part of some other problem, which is given later. I will tell you which problem. Okay, so area of these three, I have area of the this blue part. I could not show in this because maybe I forgot to attach the sheet. So you just copy it from here. So how much do you get if you cancel? You get 77 into 3. How much is 77 into 3?
Yes, sir.
240
221.
minus 6 is 234. 234 divided by 77 into 3. Not 4.
Sir, 221, I guess.
Yes, 221. 221 by 2. So I'm getting this as 110.5 centimeter square. Okay. This is the area of each of the this blue part that I have shaded. Each of the shaded region outside the square. Therefore, area of the 4 shaded regions outside the square is equal to, take the fractional one, 4 into 221 by 2. So this comes to 442 centimeter square. So what is the total area of the shaded region? What is the area of shaded region? Area of the shaded region outside the square plus area of the shaded region inside the square. Area of the shaded region outside the square we have found out to be 442. So write 442. And area of the shaded region inside the square we found out to be how much? I think 42 we found out, right? This 42.
Yes, sir, 42 centimeters.
42. So this is 484 centimeter square. Okay, so this part you just need to copy it from here. Uh, this one from here till the end. Okay, just copy it from here because I have forgot to attach the sheet. So I stop here for today.